This is an amoeba, a microscopic unicellular creature, moving in the strangest and most alien way imaginable. Its cell has no defined shape and moves by flowing like a dense liquid. This process is known as amoeboid movement. How does it work? And is it possible to build an amoeba robot from metal? The key to understanding this odd method of locomotion is ectoplasm. Ectoplasm is the clear, thin outer layer enveloping the amoeba cell like the skin of a water balloon. The high surface tension of the ectoplasm layer gives the amoeba its malleability and some base structure. Apropos structure. At first glance, amoebas seem to be pure chaos. But there is more order in this chaos than you might think. The amoeba can be separated in a head and a tail portion. The head is the direction in which the amoeba flows. The tail is in opposite direction to the flow. This tail rear end is the command center of the amoeba cell. It plays an important role in providing the energy for the amoeba's movements. Ectoplasm envelops the amoeba completely. The entirety of this layer is called the ectoplasmatic contraction tube. This layer applies pressure onto the contents of the cell by contracting from the rear. Imagine it a bit like someone is squeezing a toothpaste tube. The ectoplasm at the rear of the amoeba acts like a muscle. The contraction of the ectoplasmatic gel layer at the tail end pushes the more liquid cytoplasm forward until it gels. The gelled ectoplasm separates out and flows backwards along the membrane. The remainder of the cellular contents, the so-called endoplasm, stays where it is. The energy required for amoeboid movement is generated in the tail section. Once the ectoplasm backflow reaches the tail end of the cell, it is charged up with ATP, causing the ectoplasm to contract. The resulting pressure gradient initiates the flow by pushing the liquid contents of the cell forward. The energy-depleted ectoplasm mixes with the endoplasm and is pushed forward, where it gels and the process starts over again. So, in summary, what is ectoplasm? Amoeba movement is controlled and mediated by a contractible, high-surface tension layer. We call it ectoplasm. Without ectoplasm, amoebas wouldn't be able to move. Lastly, let's take a look at the second question. Would it be possible to build an amoeba from metal? It's quite unbelievable. I almost couldn't believe my eyes. But there is an experiment that explores how to make amoeba-like structures from liquid metal. The movement of these metal drops is also caused by a high surface tension layer, similar to ectoplasm. The layer envelops the liquid metal beneath and pushes it around into certain directions. Let's explore this more in detail in the second part of this video. Thank you so much for watching. Let's dig up some more dirt and let's stay curious.